Okay. So, ladies and gentlemen, yes, push. Oh, okay. So you need help?
Yes.
Yeah. Okay. Let's see. Ante? Is there any chance you might be able to help this gentleman here? That would be great. Thanks so much. That's a big help. Okay. Great. So in the final sort of session of the day here, we're going to put in place interventions. And, I was thinking about it, and this is a very important sort of topic with some subtleties that I'm not sure I've really done justice to on any of my other online talks. So I'm glad we're actually doing this, because there's a sort of set of tacit knowledge you build up about how to do this that's perhaps not discussed consciously. And I'd like to talk about different ways that interventions can be accomplished and some of the challenges and textured issues that come about because of this. So I'd like to examine two basic different types of interventions here, and maybe discuss some additional ones. So one type of intervention is going to be quite prosaic, but still important to discuss. So we're going to have interventions. One type of intervention lower the chance on a per year basis that someone will go from a normal to underweight state to an overweight state. Okay, and we could do this in much greater detail, but the basic gist is that we're going to have a variable that's going to be multiplying, a coefficient that will multiply this hazard. And by setting that coefficient to sort of half its normal value or a quarter, we'll be able to lower the probability per year of this transition by a corresponding amount. Or, we'll be able to lower it by a factor of 2 or factor of 4. So that's sort of one common way of accomplishing an intervention. We're going to talk about some limitations to these. I just want you to see these are sort of very familiar ways, the two ways we'll be exploring, and then we'll talk about their limitations and about deeper ways we can accomplish things. So what we're going to do now is we're going to take our model and we're going to drag in a variable here that will be called becoming overweight coefficient. Okay, it's going to be a coefficient. Maybe we'll call it becoming overweight intervention coefficient. Intervention, to connote the fact that this is a coefficient that reflects the fact that there's an intervention in place. Okay, becoming overweight intervention coefficient. It's going to be a double precision value, and its initial value will be 1.0. Okay, now this becoming overweight transition here will now be given by, the rate will be given by that coefficient times what was there already. So we introduce this coefficient, it's a double, its initial value is 1, and now for this transition we're going to have a rate that's given not just by the initial thing that was there, but by this becoming overweight intervention coefficient, this new variable times that thing. Okay? This will provide us with a way to kind of lower this and see the effects on a per person basis. Okay. Okay. Does that make sense? So, on a per experiment basis, we'll be able to change this. This is one way. And I'd like to do the same thing for the becoming obese transition. Okay? So I'd like to create a corresponding becoming obese intervention. Oh gosh. Okay, here we go. One trick you can use to do these things, folks, by the way, is you can take this, you can hold down Control, and you can drag and let go, and it'll actually make a copy of that variable with all its settings. Now all I have to do is change this, make it becoming overweight, and that's not just for variables, that's for other aspects of structure. Oh, sorry, becoming obese, sorry, what am I doing? Obese intervention coefficient. And this is going to serve the effects of multiplying this becoming obese transition, the rate in it, which right now is hard-coded at 2. We're going to make it becoming obese coefficient times this. And really, in a real model, we wouldn't want it to be just hard-coded 0.2. We'd want to have a constant somewhere in our model, maybe like we had over here for the beta, where we have that, or we want it to be specified by a parameter in main. But whatever way you cut it, this is going to be this coefficient times what was there earlier. This one is going to be this coefficient times what was there earlier. Okay? Are people okay with that? Okay. So that's one type of intervention.
So this becoming obese intervention coefficient, that's just what was the value of that?
It was 1.0 by default.
Right, okay.
In other words, by default, we just go with what was there before. It's just we're going to be able to lower it for particular interventions. Okay. Okay. Great. Okay. Now, the second type of intervention we're putting into place here is going to be an intervention which does something more substantive. It's going to shift someone back from the obese state to the overweight state. It's going to shift them back. Boom! Shifts them back. So we're going to actually put in a new transition between the obese and the overweight state. And this transition will be of a certain kind. It'll be a certain type of triggering. And I'm going to ask you, this will be called like bariatric obesity reversal intervention, something like that, or intervention transition. So we just created this type of transition. And suppose I wanted to make someone do something. I want to be able to tell them, do this, and they'll do it. If I wanted to do that transition, how would I do that? What sort of thing how could I make it do so? How could I communicate that intention to it? I could send it a what? Message. So this is going to be triggered by a message. Right. Okay. So it's going to be triggered by a message, unconditionally, and it's just going to bring someone back into that state. Okay? So these are two different types. Now, these are not all the story, but I want to put these into place, and then we can talk about a more fulsome set and some of the trade-offs associated with this. These are very common bread and butter type interventions. Okay, so, ladies and gentlemen, where do we specify these interventions? Remember, we added those parameters in main. Remember that? Remember those parameters? Where is it that specifies parameters for main? Remember, for a person, what is it that specifies the parameter values? population, the thing that creates the person. For main, what is it that specifies the parameter values in main? It's the experiment. Okay, good. So, ladies and gentlemen, we have a experiment here. These are all basically baseline experiments. These are all experiments with no intervention in place. So these things are blank. And actually, for this is person eligible, by default, you know what we should return? So if you go click on is person eligible for intervention, for that, please for the default value give return false. I think you have to say return. Maybe you could just say false. Okay, yeah, you don't say return. You just say false. That's all. Yeah, it already has the return. Okay. Yeah. Okay, fine. Okay. You say false. Boom. False. Boom. Yeah. Okay. There we go. Good. Okay. So that's for the, and that will hold for the baseline, for this simulation here. This will hold for the baseline. Is person eligible? And let's run it. Let's make sure things are still hunky-dory. Maybe you folks don't say that. At least Rob would understand. Okay, great. So it's running. Now, ladies and gentlemen, let's add a new scenario. This scenario is going to be let's make it something dramatic. Halved overweight hazard. We're going to divide it by 2. That hazard of becoming overweight. Okay. And maybe we'll say half the overweight hazard entire population. Okay? We're intervening on the entire population. Who needs Nolian help? He okay. Oh wow. Okay, we've got a code red. Okay. Sector 2 is hard hit.
Just go back to the person and show me the new transition. I was behind and missed that bit.
Sure. So we're going to go to person. Here we go. Boom. And we're going to show you the new transition. This transition here or the new one?
The new one.
The new one is here. Obesity reversal intervention transition. And all it is a message transition.
Yeah, and have we said anything about those messages?
No.
Okay.
Didn't change anything. Okay, who else needs help? Okay. Oh, great. Okay. Okay. Who else needs help? Any questions? Okay? We're cranking along. For the halved overweight hazard for the entire population. Okay? We've just added a new experiment, ladies and gentlemen. A new experiment. And I'd like you to tell me what we need to do.
Anybody else?
So we just added this experiment, halved overweight hazard entire population. What do we need to do here in the experiment? I'll give you a hint. It involves not L2Os and a P, but it involves these things here. So first of all, is person eligible for intervention? I'm saying the intervention is going to be applied for the entire population. What do you think this is going to be? I heard something encouraging. True. It's going to be true. Is the person eligible? Yeah, they're consistently eligible. Every single person is eligible. Okay? Okay, how are we going to perform an intervention on them? What is that intervention going to do to effect a halving of this hazard? What are we going to set? Coefficient, yeah. Okay, good. Good. Okay. Okay, so what we need to do is we need to set that. But we can't just say performing overweight because it doesn't know. Set it for who? For which person? Watch this. Person on whom to intervene. Oh. How did it know about that? From whence did that come? It came no less than from your own hand. We'll go and see where in just a moment. You actually typed that name. Person on whom to intervene, and what do we have to do to them? Indeed, and how will that be affected? By setting the variable to half its value. So it's setting it to 0.5. So becoming overweight, intervention coefficient, we're going to set it to be 0.5. In other words, we're going to set this one to be 0.5 so that they'll have half a chance per year of going that way. Is that okay?
And so some of you who named that argument something, just called it person or target person or something like that, you won't need to use that full name. I think actually if you just click in the box, there's that little light bulb that shows up and tells you exactly what parameters you can use.
I didn't see a light bulb.
Oh.
Yeah.
Well, anyway, you'll find out as soon as you build it.
Well, yeah, let's go see. I mean, from whence did that come? It came no less than from your hand, applied in an artful place. So let's go to main, and if you went to perform intervention for person, that's that name. We created it not 2 hours ago. No, candidate person was for the other one. This one here, is person eligible for intervention. We're talking about this one for perform intervention on person because that's the one with which we deal here. Okay, who needs help? Nolian energy is being applied. Okay. Yeah.
But this cannot be resolved to a variable.
Okay. So let's go to person. So if you drag this down, yeah. Okay, and now let's. I see it's exhibiting displeasure. So why don't you go double click on person? It seems to be unhappy about something. Okay. So can you double click on this guy? Yeah. Okay, double click again. Yeah. Okay. Yeah. Becoming overweight. Okay. So it's called becoming overweight intervention coefficient 1. That's why it has a 1 at the end. So you want to click on this guy. Yeah. And then you want to get it at the end, go all the way to the end, and it's probably because it was copied. Yeah. Okay. Now try building it. See if it's a happy. Okay, it's not totally happy, but here, double click on that. Okay. Person on whom to. Okay. So now we need to go to main.
here.
Yeah, that's wonderful. Okay, then scroll over. Or where did you put those? Okay, there you go. Okay, so let's go this thing, yeah. Okay, and then could you? Oh, this is missing a parameter. Sorry, no, it's not that. So could you scroll up? Yeah, there we go. Candidate person, it's called. Sorry.
What's spelling?
So it's actually, sorry, look at that, yeah. There is a spelling issue. But how about this one here? Go to this one. This is actually the upper. On whom. This should be person on whom. Yeah. It's not like for whom the bell tolls. It's actually person. Yeah. Okay. Yeah. Yeah. I'll put it on the big screen. Okay. Who else needs help? Who else needs the help? Okay. Help is on its way. No, I just said it in a most direct fashion. Okay? Yes, okay. If you want, yeah. Okay, yeah. So then when you're defining this experiment, you'll have to say person. Yeah, I mean, it should do person. Person dot becoming overweight Yeah, I know. I'm on to good terms with computers, but I don't like to ascribe it to that. Okay, who else needs help? Help? Okay. What's that? Okay. So ladies and gentlemen, this intervention is going to be setting their overweight coefficient to half its normal level. So in other words, they'll have half the chance per year of becoming overweight. Okay, so let's go to the next one. Let's do a halved obesity hazard entire population. Okay? Halved obesity hazard entire population. Boom. Now you're going to tell me what to fill in there. What's the is eligible going to be? True. Indeed. Okay? And how about perform intervention in person? Person on whom to intervene, or whatever the corresponding name is for you, dot what? Well, it's the name of that coefficient for that, right? Becoming obese intervention coefficient. So we need to go set that. In other words, for this person, we're setting their coefficient to dictate becoming obese to half its normal value. Okay? Compile early, compile often. Build early, build often. If any of you would like to seek the assistance of our fine TA, he stands unencumbered by other obligations. Okay, and now in the coup de grace, we are going to go and build on your learnings from a week ago today. Oh, sorry, a week ago, sorry, not, excuse me, from a day ago today. Okay, we're going to create a new experiment called called, what should we call it? Reverse obesity intervention. Okay? Call it reverse obesity intervention, entire population. Great. Okay, so what is the is eligible? What is that going to be? True. Indeed. How about perform intervention on person? What do we need to do to reverse their obesity? What did you do yesterday in this very room? Please don't tell me slack off. What did you do under the patient counsel of our fine TA? Okay, yeah, we sent a message. Right? Sent a message. So, ladies and gentlemen, let us send a message to whom? To the person on whom we are intervening. Person on whom to intervene, right? Okay, we need to send them a message. Now, from whom the message comes is not that material. I'm going to say this dot send. Oh, we can't. It's because we're in an experiment. Yeah, okay, fine. We'll just have them, fine. Okay, yeah, fine. Just send it to themselves. Send the message to them. Okay, send. And we're going to send a message. It's going to be a certain message. It doesn't matter what message here because it's unconditional. Once they receive it, they're going to reverse as long as they're in that obese state. And we're going to send it to a certain person. Okay, so we're going to send some message to that person. And we'll send reverse obesity. Boom. There we go. Okay, now there's a fly in our ointment, but that's okay. It's the basic design is sound. The fly in the ointment is no one's starting obese. Okay. So let me put that up on the big screen. Boom. Let me make sure it builds fine. Come on. Good. Okay. So this is the person sending it. It doesn't really matter who sends it. We're sending this message, reverse obesity. The actual message is immaterial here because whatever the message they receive, they handle it the same way. And this is the person to whom it's sent. Okay. People okay with that? Okay. So let's examine the impact of these different interventions. This last one is a unfair comparison, but we'll refine the strategy. Okay, so ladies and gentlemen, let's run the first. First of all, let's run the simulation, the baseline. Let's call this, instead of simulation, call it baseline. Boom. Simulation is the most opaque term. Okay, for the scenario. Okay, call it baseline, and now let's run it. And I'm going to run it, and I'm going to study in 100 years. Here's the number of diabetes cases is 75, and the number of obesity cases is conveniently almost exactly 50 for mine. 75 and 50. Great. Over the course of 100 years. Now let's go to the halved obesity. First of all, let's make sure it runs to 100. Yeah, it's running to time 100. Great. And let's run that out. We're halving the obesity hazard. And what does this contribute? Well, you tell me. How do you think it will compare? How about in terms of the number of obese individuals? Okay, how about the number of diabetics? Okay, obesity cases have been lowered to 30. Remind me, what was it earlier? 50? 50, right? Went to 30. Not quite half. Why not? Well, amongst other things, there are some stochastics and a certain amount of variability there. But yeah, it's not entirely no. So okay. So that's a one-way process. I mean, previously also people, once they gain obesity, some of them could lose it. But here, the number of diabetic cases has been reduced to about 68, maybe. Now, ladies and gentlemen, these graphs, while instructive, are hardly a sufficient endpoint. You can right-click on them and say copy all, and then you can go and you can place them in a target of your choice. For example, Excel, and get this actually printed out as a function of time. This is time here in the first column, and this is number of diabetes cases, and this is the number of obesity cases. Okay, so you may choose to exercise that option. That's great. How if we have the overweight hazard? Let's try that one. Boom. Okay, now what do we have? Well, slightly larger set of obesity cases, but it's not clear it's statistically significant. In the number of diabetes cases, we have slightly fewer, right? Now, to really do something meaningful there, we'd want to run it a number of times, and as chance allows here, we may do that. But let's go on and look at this reverse obesity. Now, this one is actually not going to be a very fair comparison because nobody starts obese. Nobody begins in an obese state. And so, at the initial time, going and setting this, sending them a message, no, it's going to fall on stony ground. There's no one who's going to receive that message and respond to it because there's nobody within that obese state to receive that message, and that's the only place that message is being processed. So I'd like to change this a little bit. Maybe we can have that obesity intervention go off at a certain time other than 0. Maybe we can have it go off partway into the simulation or go off on a regular basis. So let's go up to main. Really, if we had time, what I'd do is I'd divide people amongst these states. How many people would like to do that? Probably take about 5 minutes. Do you want to do that? Just as a recollection of how to do it? Okay, so you tell me how to do it. What do we need to do? Okay, yeah, we could go sideways, but both for expedience and time and to avoid displeasure on the part of Dr. McDonald, I'd like to instead just leave this in place, but we'll drag it up there, and then we can put in the requisite machinery. What do we need to add? A branch transition, no less. Okay. Fortunately, we've put all the things in place. Well, not all, but most. Great. And then transitions. Yep, we need transitions from that branch to each of these, right? Do we not? And do, indeed. Okay, boom. Okay. Now, ladies and gentlemen, you notice as I drag these transitions, so there's a distressing tendency for them to stretch across states. Is there not? How do I avoid that? Can anyone tell me? Can anyone remind me? Double click on it and drag. and we can route it around as befits aesthetic criteria. Boom. Okay. There we go. That's good. And now we will further route them to an obese state. Now, this is certain displeasure that I'm experiencing. Okay. Great. So we're going to route them to the obese state here. Get them to enter the obese state. Fine. Now, if we wanted to force them to enter the disabled state, things would get a little bit more sticky. We could, that will get a little bit more hairy. Maybe Dylan has an idea in mind, but I think it's best we pick our battles carefully here. Getting them to force them into that disabled state. There's ways of doing that, no problem, but they would be a little bit. They'd lack some elegance.
Depends how much time you want to put into it. Whether you could just put another arrow straight down to 808 disabled, did you want?
Sorry, another.
Can't.
No, you mean can I penetrate?
Yeah, can't you? I mean, you could just put.
I thought that wasn't allowed, but it shows no.
We'll find out very shortly.
It shows no displeasure. Okay, let's soldier on. Sure, let's give it a try, and then let's observe the results. This is not a chemistry lab, but a simulated world, and incurring the displeasure of any logic carries little cost. I speak of the software rather than the corporation. Okay, so we want to add now a parameter that's going to encode the initial what state? Initial weight state. We're almost done. Initial state. Okay? Great. This is a rehearsal. And what sort of parameter would that be? This is not a rehearsal. It's a fugish revisitation, a fugish sort of rehashing of this. Okay, so the initial weight state, what should its type be? Weight state. Good. Great. And based on what parameters, based on what conditions do these various transitions emanating from the branch depend? I'm going to give them nice names. This is starting, normal weight, and that, ladies and gentlemen, will be the default, the genuine default. Starting, normal, and underweight. Great. Oops, underweight. Happy. Okay. This guy will be called starting overweight, and under what condition will that happen? Under what condition? This is a rehash. This is not a first time, so you should be able to tell me, perhaps even in a stentorian voice. What?
Initial white state equals.
Yes. Indeed, stentorian. Indeed, I appreciate the clear articulation. Initial weight state equals overweight. This is basically what we did for the other state, but it's a generalization to the fullness of the set of states here. This is going to be starting obese. Starting obese able. And this one, which we hope will not incur the displeasure of any logic, will be based on a condition that's what? speak now as if in a Greek chorus.
Initial,
Good. Yes, yes, I hear a hint of Greek in the terminology. Initial wait state equals what? Oh, sorry. Is it equals or is it, sorry? Equal. Okay. If it equals what? Obeseable. Yeah. Okay. Which is being realized here, unfortunately. The person's obeseable. Okay. In this transition into the disabled state, we'll call this becoming obese disabled. And based on what transition condition will that be based? Initial weight state double equals obese disabled. Okay, great. We're almost home free now. We're almost home free, are we not? What do we still have to do? I know you're probably thinking you're almost home free. Okay. What do we have to do still? So we provided this mechanism, we provided this new parameter, and every time there's a parameter, what is incumbent upon us? What must we do for the population? When we specified this parameter, what should we do? We need to specify the assumptions about that parameter. Yes, which are specified where? In Maine. In what part of Maine? The population. Man, you folks are good, if hired. Okay, so in population, we're going to say the initial weight state. Okay, we'll finish this little thing with its appropriate flourish. Okay, we're going to add in a distribution, a custom distribution. Tell me whether to go. Agent, good. Wow, you folks are great. Oh, look at that. My agent disappeared. Look at that. Do you see? Yes. So what do I have to do to fix that? Has anyone encountered it?
Yeah, there's a plus.
There's a plus indeed. And that plus will remedy the situation. So now it's restored. Plus down here will allow you to add and remove pallet items. So here we are. We can put in a custom distribution, and this is initial weight distribution. And what type is it? Is it continuous? Is it discrete? Or is it options? Indeed. And the option list is what? Weight state. Good. And you can pick your numbers. I'll make it 60% normal and underweight, or say 65% normal and underweight. I'll make it something like 25% overweight. I'll make it so I'll make it 7% obeseable or obese able, and 3% obese disabled. Right? So that's what I am doing. Those are not privileged numbers. They lack great significance. Okay. So, having done that, ladies and gentlemen, we stand to okay, thanks. Yeah. So having done that with the initial weight distribution, what do we need to do? Oh, you know what? I put this in a most unseemly place. A place that's most inappropriate. Where did I put it? In person. It does not belong in person. Where does it belong? In Maine, indeed. With the other custom distributions like it, perhaps. Okay, I'm going to put it abutting these. I can click on the other and paste and then move it around with the arrow keys. Okay, great. Great. Okay, so having imposed that, having described that distribution, how do I impose it upon the population? Riddle me that. Good. Good. Initial weight state equals initial weight distribution. There we go. A thing of beauty. Or at least a thing of utility. Okay. May I be pardoned? Could I get a bit of water from somebody? My supply has been exhausted some time ago, and my throat feels it keenly. Thank you. Okay. Okay, so ladies and gentlemen, shall we compute? Compute or not? Compute. Let's run the baseline and let us re-examine numbers in light of the baseline. I just ran it. Oh, we something grim indeed. Okay, so it's 85 diabetes cases and about 52 obese cases. Ladies and gentlemen, let us run in turn each of those intervention strategies that we have designed. So, I'm going to run the halved obesity hazard. Oh gosh, I pressed the wrong thing. Okay, I need to go back. I need to run halved obesity hazard. Go. And let us run it out. There we go. Okay, halved obesity hazard, we went down to about 70 and 30. Not bad. Not bad at all. Okay, next run the overweight hazard. Boom. Okay, it went down below 70 and again to about 30 something. Not too bad. Finally, let's run the reverse obesity. Okay, we're going to run out. Here we have a level at 75 and a level of for 75 for diabetics and above 40 for obese. So we see some comparisons there. But what am I failing to capture, ladies and gentlemen? What am I glossing over? Well, there's actually significant variability between the different runs for a given scenario. So, ladies and gentlemen, I'd like to expose you to something that may trouble you, but something of which you need to be aware. Perhaps that's been a theme throughout this week. But let's go take a look. So if you go to one of these scenarios and you scroll down, you will find that there's an area called randomness. And you'll notice right now it's running with a fixed seed. What that means is that every time it runs, it gets reproducible results, which is much to recommend it in the scientific method, and will often seek recourse to that. But if we want to compare interventions in a reliable way, we have to recognize that interventions will tend to differ between realizations. In the words of Dr. McDonald, in critical realism, I understand they term the actual world and what's the other term, the physical world? The actual world includes counterfactuals. Or no, the actual world is the actual realized observed case, but it's just one of many possible ones. Is that right? Well, perhaps it's not worth going into right now. Yeah. Okay. In any case, ladies and gentlemen, I'd like you to change for the baseline this from a fixed seed to a random seed. Okay? For the baseline, fixed to random. Let's run this. And what we is, if we run this out for the baseline, in different ones, we'll see slightly different results. Here we lacked quite as big a number. We have something like 82 and something like 50. Let's run it again. Here we go. We have something like 82 and a bit under 50. Number of diabetes cases seems fairly stable there, but let's run it again yet another time. This is something like 79 and 50 some odd. So you actually see there's quite some variability within a given scenario. Tomorrow, we will see how we can capture this variability in our runs using what's called parameter variation experiment and get some sense of robustness in our evaluations by capturing the range of outputs of a given scenario. That lies before us, but we don't have time to explore it today. I want to use the closing minutes of today to talk about what we've done for interventions and talk about a broader set of options. We've put into place two types of interventions here. Two types that are recommended by their commonness, and hence me passing them on, but that are not terribly privileged in terms of the in the space of possible ways you could do things. These interventions are blunt in terms of their impact. They lack a detailed representation of some of the mechanics, particularly for the first type, where we have the impact captured for this hazard rate, for these hazard rates. The last intervention, where we sent people a message, is more fine-grained. Send people messages based on their characteristics, potentially. We haven't exploited that yet, but we will. But here, ladies and gentlemen, we have a depiction which is fairly simplistic in its depiction of an intervention. All it does is tweak a parameter. And in general, ladies and gentlemen, when we simulate a parameter, it's not always so easy to assume an impact on a particular transition, such as the likelihood of becoming overweight. A more robust, or certainly deeper type of approach would be to have an intervention on another piece of the model, say physical activity, which rippled through to affect this transition. Here we've simply imposed it in a broad brush sort of quite presumptive manner. We've assumed, okay, this intervention, suppose this intervention lowered this value, and that's fine to assess sensitivity. It's fine to say, okay, how much of a difference would it make if it were here versus lowering this rate here, or sort of enhancing this rate here. It's fine for basic sensitivity, but when we want to simulate actual interventions, this is a very coarse-grained way to do so, if we want to simulate particular interventions. As a result, one is advised to think about instead capturing a situation where the effects of the intervention are emergent. You put in place an intervention, and not merely does it. Okay, so, excuse me. I'm gonna refine my statement there. the effects, what I just said is the effects of the intervention. We're advised for strategies where the effects of the intervention are emergent. That was a poor way of putting it. The effects of the intervention, it's nice to have it, so the effects of the intervention on behavior are emergent. And that's not the case here. We're sort of tweaking this and we're seeing the distal implications of it, and that's something significant. But as I said, it's very presumptive. We're imposing this assumption about how it will affect things in terms of a fairly important process of behavior change, or excuse me, of outcomes in terms of weights. But really, we don't have the option in our interventions of directly changing people's weights. Instead, what we have the option of is often undertaking activities which we hypothesize will nudge their behaviors in some way. And by simply having this rate, it's not clear in what specific ways that's accomplished. In what way would we need to change their behavior in terms of nutrition, in terms of physical activity, in terms of sedentary behavior? In what way would this need to be realized to have this value? So as I say, that's fine for basic sensitivity. It's fine for basically assessing the relative impact of an intervention here or elsewhere. But it's a very coarse and crude instrument for asking about actual interventions. Actual interventions would be better considered by capturing some of the factors that would lead to this change and having them be emergent, so that rather than presupposing an effect on this rate as captured by that transition, rather that change in rate will be affected as an emergent property. So, for example, we might simulate through aspects of an agent's preferences, providing some tax incentives for activity among children, or involving certain types of school activities that would provide greater levels of physical activity. And those effects might be captured then in the model in terms of their ripple through in other factors that are germane to this. Perhaps it enhances physical activity or enhances nutrition, and that ends up having perhaps that same effect of halving this. But rather than imposing it and presupposing it without knowing how to accomplish it, now we'd be capturing the causal pathways that lead to this. So, while what we've done here is instructive, it can give some model learning, one shouldn't fool ourselves into thinking we've captured the mechanisms of interventions in detail. Rather, we've captured something about where to intervene. It gives some insight about where to intervene, but not so much how to intervene with respect to this transition. How to intervene is best investigated if we have additional components in the model that will ripple through to affect this particular transition. So rather than imposing it with a parameter alone, we see it as a ripple through effect. Now, with respect to diabetes, the fact that we've captured these things related to weight state means, we've done ourselves a service. We haven't simply said, suppose we can have this rate. Rather, we are seeing distal implications from here ripple through to here. So we are looking really upstream of diabetes. But even so, it would be nice to bring guidance in the area of policy discourse to exactly what ways we would accomplish this. Through what programs these would be realized, through what specific intervention options. We still have brought something of value to the table, particularly in understanding how to lower the diabetes burden by capturing these mechanisms. But we would like options that are finer grained. Now, this brings us full circle back to the issue of this sort of modeling. Because capturing things at an individual level affords us an opportunity to capture individual preferences. It affords us an opportunity to have interventions that are designed to take into account a person's history. It affords us a chance to have interventions focused on individuals at prominent positions of a social network, or who are in a particularly vulnerable spatial position, such as in a food desert. And if time affords us tomorrow, we'll be seeing things like mobility models, where we'll actually be simulating the day-to-day behavior of agents as they go for food to convenience stores or to grocery stores in a way that will shape the health of their diet. A model like that would allow you to ask about fine-grained interventions, say suppose we were to place grocery stores in this region, this particular region of a city, or suppose we were to increase the availability of good fruits and vegetables through markets in the city. How would that ripple through to healthy eating, and how would that ripple through then to weight and in turn to development of diabetes? So in that sort of model, or similar models on the walkability area, sort of issues of how the physical environment around me affects the walkability, and now my walkability is something that if the environment shapes me, it shapes based on my characteristics, my likelihood of going walking, hence my physical activity, hence my change in weight status. Those are very powerful things, and they're concrete. They have to do with that nexus with policy discussion in a way that a kind of blunt changing of this rate does not. Changing of this rate also smacks to a certain degree of top-down kind of planning, that you're going to be able to just make this happen. Whereas often what happens to shape the outcomes of interventions is an emergent process that involves the ins and outs of sort of individual preferences and interactions between those individuals, spread of weight norms, etc. So for all these reasons, what we've looked at here is a beginning, and it's powerful, there's no question. We haven't had time to talk about it, we may tomorrow, but each of these interventions we could then apply to subsets of the population. And I'll show you very briefly how that's done. If we were to take this, have the obesity hazard, and we were to copy it, and we were to paste it back in here, and we were to change it to be have the obesity hazard for obesity hazard children, or say children under 15. What would we do here? What would we change to make this apply only to children under 15? Where would we go to modify it? Whither would we go? Yeah, is person eligible? Actually, it's is person eligible to intervene? It's this that we would modify. And how would we put in place a check? What formula, what so-called expression would we need to write to test if a given person whose name is candidate person, a name that came from your own hand, that if we wanted to check if candidate person was less than 15, how would we do that? Sorry? Candidate person dot current age is less than 15. No, you just say that. That's it. And now we could simulate, intervening upon just that group by preventing obesity, for example. Very, very, very powerful. we're able to kind of look at intervening where in the system for different subsets of the population. But it's really this practical policy discourse that points to some of the greatest benefits of this model. This model is great in that it allows us to understand the distal impacts, for example, on diabetes, of impacts on weight. But to really get to the nub of it, we want to tie it into some additional aspects of health, specific health behaviors. Where is the behavior in this model? Wherein lies it? It has eluded us in many ways. We see the changes between these health states, and that's all well and good. And ladies and gentlemen, often in the realm of models, we crucify our policy discourse in those models upon this cross of depicting these sort of rates of change among health states in an opaque way. And I would ask you, I would submit to you to consider the importance of including some representation of the human behaviors behind these. Because it's those human behaviors that we have a chance to nudge. And it's those human behaviors, understanding the outcomes of our possible nudges, of our interventions, that is almost as arguably equally as important as simulating these sort of changes between health states alone. The changes between health states, there's all sorts of complexity associated with this, and understanding the distal behavior, the distal impacts of intervening at certain places of the system is important. But really, there's a lot of questions also about if you intervene in specific ways on people by raising a tax or by prohibiting sale of sugar-sweetened beverages to people under a certain age, or restricting the set of outlets that can provide them or the beverage size. How do those things ripple through to actual consumption, to the behaviors day to day? And how do those ripple through to these issues of changes of health state? There is some intriguing evidence in that areas. And it's really to that new frontier that much of this modeling offers the greatest potential. So I would ask that as we go forward tomorrow and we see some of this illustration of these finer grain models, looking at the micro behaviors that might underlie these changes, we reflect on the fact that it's characterizing things at that level that will provide us with the clearest lens on in terms of comparing intervention A with intervention B. A model, rough and ready like this, can provide a way of kind of looking at where to intervene, but it's really bringing in these individual behaviors. We have the clearest understanding of how to intervene. So we're going to be taking a look at that, and those things will play to the strength of models, of these sort of models. We can take into account individual preferences. We can take into account people's limited sort of their situated character in particular neighborhoods or social networks, the fact that they have limited social capital and they have information only about certain things, they have incomplete knowledge about other things. These are the sort of things we can exploit. And these are the things that we do well to address real-world policy discourse. So we'll be talking about this tomorrow, and at least Dylan will be showing a model, perhaps building up a model now that involves some aspects of this kind of behavior in terms of food acquisition in the food environment. So that lies before us tomorrow. Are we at a time of closing for the day? So I'd like to thank you for your patience, your attention, and your willingness to stick with this through a very difficult day. We confronted and we overcame some of the biggest challenges that I have yet seen in a boot camp. You deserve every bit of respect and and admiration for having overcome these rigors. Tomorrow will not be nearly as trying, but hopefully it will be eye-opening in terms of some of these additional components. So thanks very much, and we'll see you tomorrow morning. Yes? Oh, okay. Sergeant Dillon reports.
If anyone got anything to really burn in particular, please let someone know. They just can't survive without having it covered.